Test x squared over 9 minus y squared over 16 equals 1 for each type of symmetry, then check the graph using Desmos. This is an equation that has a much more complicated graph. In fact, this is something we're going to see much later in the semester, but for now we are able to test for symmetry and then look at the graph using Desmos. So we'll start with symmetry with respect to the y-axis. Remember, the rule here is to replace x with negative x. When we do that, we've got negative x squared over 9 minus y squared over 16 equals 1. And we know that a negative times a negative is a positive, so that ends up becoming positive x squared over 9 minus y squared over 16 equals 1, which matches the original equation, and so we know that we do have symmetry with respect to the y-axis. Let's check the x-axis now. To do that, the test asks us to replace y with negative y. When we do that, that gives us x squared over 9 minus negative y squared over 16 equals 1. And just like in the last example, we know that when we have a negative and square it, those negatives cancel. So this is going to be the same as y squared over 16. And again, this matches the original equation. So we know that we have symmetry with respect to the x-axis. Now let's check the origin. And remember, to do that, we need to replace both. Specifically, x gets replaced with the opposite of x, y gets replaced with the opposite of y. So we're going to have negative x squared over 9 minus negative y squared over 16 equals 1. And just like in the last examples, when we have a negative quantity that gets squared, the negatives cancel. So we've got x squared over 9 minus y squared over 16 equals 1. Again, this matches the original equation, so we do have symmetry with respect to the origin. And so in this case, we have symmetry with respect to the y-axis, the x-axis, and the origin. All three types of symmetry are exhibited here. Let's take a look at what the graph looks like so that we can explore this visually. This is the graph of x squared over 9 minus y squared over 16 equals 1. The shape is called a hyperbola, and we will spend a few lessons looking at hyperbolas towards the end of the semester. But for right now, let's just look at the symmetry. Let's start by looking at symmetry with respect to the y-axis. If we pick a point on this hyperbola, we can see that the corresponding point on the other side of the y-axis is also on the graph. And this is true with any point that we pick, so we have symmetry with respect to the y-axis. Let's look at symmetry with respect to the x-axis. For any point that we have on this hyperbola, there is a corresponding point on the other side of the x-axis, an equal distance on the other side. So that shows us that we have symmetry with respect to the x-axis. And then let's take a look at symmetry with respect to the origin. For any point that we have on the hyperbola, we have a corresponding point across on the opposite side of the origin. I'm trying to draw this as best as I can. So we do have that point over there. And so we do have symmetry also with respect to the origin. So we can see even visually here that this graph is symmetric with respect to the y-axis, the x-axis, and the origin. There's a whole lot of symmetry going on here. As I mentioned earlier, we will focus on hyperbolas later in the semester. In fact, we'll have a whole unit on what we call conic sections, which include an in-depth look at circles, parabolas, hyperbolas, and then also ellipses. That's going to be the fourth shape that we look at. But that's going to be a few months away. Right now, we're just looking at symmetry.